Okay, today we're going to be talking about climate change again, and we're going to be focusing on government strategies for combating climate change. What do we actually do about this situation now from a governmental perspective? Okay, so let's begin by just reiterating what the stakes are here. Many scientists believe that we are nearing the so-called tipping point beyond which the impacts of climate change will be irreversible. So to limit that irreversible and or highly damaging impact on both the environment and on our societies throughout the world, we have to limit the change in the global mean surface temperature to less than a 2 degree Celsius increase, which is equivalent to a 550 parts per million level of carbon dioxide concentration in the atmosphere. So if we can keep it under 550 parts per million, less than a 2 degree increase in temperature, we can keep it under that tipping point. Above that, we may be in some trouble. So why isn't there more being done at a national and international level to curb emissions and build resilience to environmental changes? Well, several factors. Namely, two that we're going to discuss is that not all groups throughout the world face the same risk exposure. That's both within a particular country and at the international level. Not everybody's going to be affected in the same way by the risks of climate change. And many of the most vulnerable people in the world have the least power and the least influence to enact change. We talked about Bangladesh in a previous presentation and how vulnerable they are. Well, it's a very poor country, does not have a tremendous amount of influence on the international stage, so they're not going to have a whole lot of power to compel other countries to change their behavior. Okay, so what are some of the factors that can impact the perception of risk and the actual vulnerability of a population? Location. Where do you live? Do you live in Bangladesh, a low-lying area, or do you live in a high altitude area that's not going to be affected by sea level rise? What is the wealth of the country? Do they have the ability to adapt, or are they too poor to adapt? The education level. How well do they understand the issue? How well educated, how much exposure to the science behind climate change do they have? The age of the population. If it's an older population, they may be kind of less open to some of the new information that's coming out. And the influence of media and leaders. Just have an example of a tweet from President Trump up here, and fairly skeptical about the reality of climate change. He's an example of a leader that commands a large audience and is very skeptical about the issue. So there are people like that throughout the world. And there are also media groups that are very influential that promote skepticism as well. All right, so there are three main strategies that can be used to tackle the issue of climate change. The first is to do nothing. Just kind of let nature go its course and see what happens. The second is called mitigation. This is referring to a wide variety of strategies that are aimed at addressing the root causes of climate change, mainly by reducing greenhouse gas emissions or capturing carbon that's already in the atmosphere. And the third approach is adaptation. These are strategies that are designed to adjust to the changing realities of conditions, rising sea levels, for example. And these last two, mitigation and adaptation, are not necessarily mutually exclusive. In many cases, governments are choosing to use both of these strategies. Okay, so let's talk about mitigation first. Some examples of mitigation, of reducing the root causes. Energy conservation, energy efficiency in our industrial activities, in our transportation, things like that. Using renewable resources rather than fossil fuels. Using more sustainable transportation like railroads versus trucks. Using landfill and sewage digester gas. Okay, so landfills, for example, produce a lot of methane, which is a greenhouse gas in and of itself. It's going to go in the atmosphere. So harnessing landfill methane gas and using that as a fuel source rather than just having it go unused, and then using that to replace other sources of fossil fuels. Carbon sequestration and carbon sinks. Right? The most obvious example of that would be planting trees, which can actually capture carbon from the atmosphere. Common to mitigation approaches is that they are rather expensive, up front, very expensive to, for example, put in high-speed rail systems in your country. All right, adaptation approaches. Some examples of these: relocating and changing the land use of particular plots of land. So literally moving out of the way of the problem. Business contingency planning. How do businesses react if they're flooded or if various kinds of extreme weather happen? Upgrading buildings and infrastructure. Providing education and training to people of how to adapt to the changing climate. Spending more on health as certain kinds of diseases become more prolific. Now, for adaptation approaches, they tend to have higher long-term costs, okay? Because it's not really doing anything by itself to address the underlying problem. So in theory, climate change will get worse and worse and worse, and you'll have to spend more and more and more over the years to adapt more and more to the changing environment. Okay, so common to both mitigation and adaptation are some things like building efficiency. You want to have better insulated buildings so they use less energy, green infrastructure, using more sustainable products, and conserving resources as much as possible. All right, let's talk about international agreements. So there have been, climate change has been a big topic on the international stage since the 80s at least. And this kind of culminated in the most significant international agreement to date in 2015, which is the Paris Climate Conference, or COP21, and resulting in the Paris Climate Agreement. So the Paris Climate Agreement was designed to limit the global mean standard or surface temperature increase to a maximum increase of 1.5 degrees rather than the 2-degree tipping point that we talked about earlier. It has been signed by 195 countries, although not all 195 have actually ratified it. And countries under this agreement are able to set their own greenhouse gas contribution goals, and they're supposed to reevaluate those goals and increase them every few years. So that's actually one of the controversies of it, is what effect does it really have if countries get to set their own goals. Okay, more on the Paris Climate Agreement. The general premise is that greenhouse gas emissions can rise, but the increase of greenhouse gas emissions should slow over time, and we will need to increase our carbon capture technology in the future so we can start taking some of that out of the atmosphere. Emissions targets are set by the countries, but reviewed and increased every 5 years. Countries have to keep and share accurate emissions data with their international partners around the world, almost as a sort of a shame factor to hold them accountable. Rich countries are encouraged to share technologies with developing countries and help countries that are vulnerable with funding to help their people adapt to the changing environment. And developed countries are also expected to acknowledge that they have a larger role in the historic carbon stock contribution that they have made over the years. Okay, evaluating the Paris Agreement, strengths of it, it's been signed by a lot of countries. Almost all the countries in the world at one point, although some have since pulled out of it, including the United States. Many countries, most of the countries in the world signed it initially. Offered some hope of avoiding catastrophe, offers some degree of flexibility economically. Countries get time to adapt and set their own goals. Does provide for accountability in that they get to review each other's data, and offers some degree of justice for poor and vulnerable countries that are most harmed by the historic carbon stock that's been contributed by rich countries. Weaknesses of it, large cuts are going to be necessary by 2050, but there's concern that there may not be enough teeth in the agreement to actually make countries reach those large cuts by 2050. Political and economic volatility around the world can change countries' priorities. So, for example, in 2016, when President Trump was elected, he was an opponent of the Paris Climate Agreement. So as soon as he came to office, he withdrew the United States from it. Greenhouse gas cuts rely on technology that hasn't yet been developed, so we're just expecting to develop that, which may or may not happen. And only a statement of intent is what really this agreement is about. So there's really no substantial consequences for countries if they actually meet their commitment that they've bound themselves to. They're only intending to meet that greenhouse gas limit. All right, European agreements. The European Union is the largest group in the world of high-income countries. They have, on their own, accepted a major role in historic carbon stock contributions, and they have made an agreement within their own group to cut greenhouse gases by 20% by the year 2020 compared to 1990, and by 80% compared to 1990 by the year 2050. All right, some other ideas, policy type ideas for limiting greenhouse gas emissions: carbon trading and carbon offsets. Carbon emissions trading, or CET systems, are a mitigation strategy intended to reduce emissions. They provide, are an example of an environmental economic system that relies on market forces rather than on pure regulation. And essentially the idea is that businesses and consumers will favor low carbon options if they are less expensive. So there's an incentive there. Also known as a cap and trade system, essentially a business is given a particular limit, how much carbon they can emit. If they fall under that cap, they can actually sell their excess space to other companies that are having trouble meeting their emissions cap. If they go over it, they obviously have to purchase it or pay a fine. All right, the European Union, again, we talked about them a minute ago. They have their own emissions trading system, similar to what we just talked about, which was established in 2003. Participating power plants, factories, and other emitters are given a set carbon credit or allowance. If they exceed it, they pay a fine, or they can buy unused credits from other companies. And those who do not use their entire allowance can sell the excess for profit. So there's the incentive and there's a disincentive if you do not reach your limit. And the number and the size of your credit is reduced over time. So you have to improve your performance over time. It's been criticized as not being all that effective thus far because they have issued too many credits, which has limited the effectiveness and the incentive for companies to really have to cut back. All right, carbon offsets are another mitigation strategy. This is designed to compensate for emissions-causing activities that are achieved by saving emissions elsewhere. So, for example, you could plant a tree to offset a airplane flight or a long car trip. There are various companies out in the world today that offer these kinds of services, and these have generally been criticized for lack of accountability. How do you really know someone is planting a tree somewhere for you? And also, they have a relatively small scale comparison to the overall emissions problem that we have in the world today. Finally, technological fixes and geoengineering. These offer some hope for future reduction of emissions and the carbon stock that's already in the atmosphere. So that's a difference from some of the other things we've talked about. They generally aim to do one of two things: either to remove carbon dioxide that's in the atmosphere or to reflect sunlight, so we're not getting as much solar radiation. All right, one of these methods is called carbon capture and storage. The idea is that you capture and store fossil fuel emissions that are being released right now. You store them underground. So essentially the way it works is that carbon dioxide is separated from a power plant's emissions. It's compressed and transported somewhere and then injected into porous rock layers and trapped under the ground. This is potentially something that could be really effective for coal power plant emissions, which is still a major source of energy throughout the world. But on the challenge side, it is unproven thus far, very expensive, and you have to figure out how to keep it underground. And then finally, solar reflection methods. These are designed to reduce the amount of solar radiation that reaches the surface of the Earth. Probably the most kind of exotic, out there type of strategy we've talked about. So one example is placing mirrors in orbit to reflect sunlight. Obviously, it would be very expensive, could be dangerous, could have unintended consequences. Injecting reflective particles into the upper atmosphere, cloud seeding, that type of thing, designed to have the same effect as a volcanic eruption or an impact event that causes global dimming. But again, possibly a lot of unintended consequences here. Could disrupt natural weather patterns, could cause international conflicts, could contribute to ozone depletion. Another idea is to seed clouds by spraying seawater into the atmosphere to make clouds whiter and more reflective, thus increasing their reflectivity.